Well, welcome. Thanks for joining us on this snowy day. I assume it might be snowy where all of you are. I'm Melissa Scanlon. I am a professor at the School of Freshwater Sciences and direct the Center for Water Policy. We have been gathering people in these webinars throughout the academic year through the Freshwater Collaborative Water Policy Network, which is a network across the entire system of people who are researching in the areas of water policy. And what we've been trying to do throughout the year is have people who are in the network give talks about their current research and kind of weave into that some discussion of the research methods that they're using so that we're not only learning about the cool things that everyone's doing with their research, but being exposed to different research methods that might be outside our own discipline. So really happy to continue on that track today and see so many people here. We're going to be recording this and we'll have it posted on our website as well, so you can share this with others if you enjoy this webinar. So Emma, I want to turn it over to you. Emma's been working with us all year as a Sea Grant Fellow and a water policy specialist, and she has been coordinating the network for the year. So she'll be introducing the speakers. And as I turn it over to her, I'm going to post our website link into the chat so people can check out the network website if you haven't visited it ever or recently. There's a description there and a database of everyone who's in the network.
Well, thank you all for being here. My name is Emma Ehrlich. As Melissa mentioned, I'm a water policy specialist at the Center for Water Policy, and I'm also the Water Policy Network Coordinator. I'm excited to introduce today's speakers, Adena Rissman and Eric Booth. Adena is a professor in the Department of Forest and Wildlife Ecology at UW-Madison and the university representative for the Wisconsin Council on Forestry. Prior to becoming a faculty member at UW-Madison, Adena obtained her PhD in environmental science, policy and management from UC Berkeley, and her lab now works on understanding relationships among people, institutions, and ecosystems, and improving natural resources management and conservation. Our other speaker, Eric, is an assistant research scientist at UW-Madison in the departments of plant and agroecosystem sciences and civil and environmental engineering. Eric has a PhD in limnology and marine sciences from UW-Madison and a master's in hydrologic science from UC Davis. His research focuses on the interactions between water, land, climate, and humans. So now I'll hand it over to Adena and Eric.
Great. Thanks so much, Emma. And it's a treat to see a number of familiar names and folks I look forward to hearing from as well and meeting in the future. So Eric and I have been working together on this project, also involving a number of other folks that we'll talk about, both an advisory board, a lot of people who've contributed through interviews and conversations, and a number of students who have helped. And we're going to be presenting this work that we called Bridging the Disconnect, Ideas for Farm Standards and Systems to Achieve Phosphorus Goals in Wisconsin Lakes and Streams. And we put out a report back in the fall called Bridging a Major Disconnect. And I'll share a link to that report as well in the chat if folks want to check it out. Oh, thanks, Eric.
Yep.
Great. And so I'll just invite you to read this quote from a county conservationist that we talked to. This is where this word disconnect that comes into the title of the report comes from. Really seeing, we have our rules about water quality, but we've also got, our water quality conditions, and then what folks are seeing in the fields. And that is this idea of the disconnect that we are really looking at a lot of people's ideas to summarize and synthesize a lot of different perspectives and options on how to bridge the disconnect. So we talked about two different questions One is, what are community perceptions toward tailoring water quality policies to social, agricultural, and hydrologic contexts, which is just to say, how do people think? So we're not saying what we think is necessarily the one right idea, but we're saying across all of these conversations, what do a lot of other people think are some good options for how to better tailor water quality policy to work for people, to work for farming, and to work for our water. And then second, through a lot of the modeling that Eric has been doing, are we achieving phosphorus mass balance? He'll explain what that means as part of a broader effort to align agricultural land management policies and standards with water quality outcomes. And you can see from the map that there's a decent number of watersheds and water bodies that have impairment for phosphorus and that have a plan through the total maximum daily load process that's laid out through the Clean Water Act to try to address that phosphorus and draw it down. So I know we're thinking about methods for this seminar series. So we wanted to share a few of our methods. We did develop an advisory board. This particular project started in the Northeast Lakeshore, like Door, Kewaunee, and surrounding counties. So we started there, but with some statewide representation as well. Similarly, with our interviews, we also started in Northeast Lakeshore, but then expanded out to state and regional interviews. We also, and this is the work that Eric led, looked at a lot of analysis of empirical data. So what's going on in the streams? What are the drivers of nutrient loss? And then doing the modeling of that with Snap Plus and Smartscape. And then I've ended up including a method here that is, we got a lot of substantial feedback on the report from people who we interviewed. So everyone that we interviewed, we sent back the report to them to say, do you like how we've represented your quote? And do you have like other edits? And that's part of what I would think of as a participatory action research or participatory approach to doing the work. I'm also just going to put in a little bit of a teaser from two other projects. One is a dairy farmer survey from Wisconsin. And I have one slide toward the end on a network diagram from workshops through the Grassland 2.0 project that a number of folks on the call here have been involved with to look at expanding grass-based milk and meat production in the upper Midwest. Next slide. Thanks. Eric.
Great. So hi, everyone. Eric Booth. Thanks again for having us. And as Adena mentioned, we're kind of going to do a little bit of a mix of a presentation highlighting some of the methods that we've used on this project. We kind of come from two disciplinary or different disciplinary backgrounds. And so you'll see quite a mix of things deployed to this issue as we go through the presentation. But obviously, there's kind of a larger story that we're trying to tell here related to this disconnect. So I wanted to start with kind of setting the stage of how I view this problem and start with a little bit of empirical data analysis, things that I haven't done personally, but kind of illustrate the methods. So when we look at water quality trends in recent decades, we have seen some good progress on the phosphorus side of things. And the figure I tend to use to express that is from the DNR and their long-term water quality monitoring network, where we see these are kind of the masses of phosphorus through time in different watersheds. And we see pretty big declines, like in the Rock River, we notice a pretty dramatic decline through time and some smaller reductions in other places. And so there's been a lot of improvements related to wastewater treatment plants. That's a large part of the story with Rock River watershed, but there certainly have been some non-point improvements as well. A little bit closer to where Adena and I are, there's a lot of data on phosphorus loads to Lake Mendota going back even earlier than this graph, but starting in kind of the early 90s, we had a real nice regular monitoring database to look at this change. And the main message there is, despite a lot of efforts on non-point source control, there hasn't been much change. There's pretty much been a flat line. So it's a little bit of a mixed picture across the state. On the nitrogen side, which we're going to just mention quickly here and then set it to the side and focus primarily on phosphorus, loads are definitely increasing across the state. And so it's a little bit of a different story than for phosphorus. But when we focus primarily on phosphorus, we have an immense challenge still, even though there have been some signs of progress in some places. And again, I'll go back to the map that Adena first showed related to these impaired waters, specifically for phosphorus throughout the state. And then these different efforts to try and analyze further what are the reductions necessary to meet water quality standards. And if you look at those reports, you'll often see reductions of well over 50% required to meet these standards. And so that is a big, big number and a big, big challenge. And so that challenge is also kind of at the heart of this disconnection that Adena first mentioned. And it's not solely in the realm of policy, like it's just how we talk about this issue too. Like we have goals for water quality and we see that we're not meeting them everywhere. But specifically on the policy side of things, we have specific laws and ordinances that we can look to and analyze and kind of dig into a little bit more detail on what exactly this disconnect is. And so I'm just going to briefly go through kind of these two different tracks of water quality standards and agricultural standards that we have in the state of Wisconsin. And I will give a shout out to Melissa and her former student Anya's paper that came out last year on the phosphorus paradox. It nicely lays out a lot of this if you want more details. But quickly, the water quality standards in the state of Wisconsin ultimately come from the Clean Water Act federally, but we have this kind of state federalism approach. And so Wisconsin can implement that in a unique way. And so we have NR 102, which establishes numeric criteria for phosphorus in different water body types. And that was updated quite a bit about 15 years ago. And then there's NR 217 that has numeric criteria for phosphorus coming from point sources. And so we have these two different sets of criteria that we now need to comply with. And if water bodies in NR 102 are not meeting those standards, then they can be listed on the impaired waters list, and that can trigger this kind of TMDL process where we can use data and models, again, to determine that necessary P load reduction. But importantly, you are kind of restricted in the TMDL process in terms of remedies or achieving those goals to existing programs. And so that's where it leads into the ag standards. So obviously not all phosphorus getting into our water bodies comes from agriculture, but it is a dominant source across the state. So I'm focusing primarily on that here. So the Clean Water Act also comes into play on the ag standards, and Wisconsin has really led the way on implementing this at the state level. So we have NR 151, where there are some established restrictions and requirements for all farmland and requirements for nutrient management plans. There's this specific phosphorus index, which I'll go into a little bit more detail in a second, that needs to be below a value of 6. And again, that's roughly how much phosphorus is coming off of a field in pounds per acre per year. And that number needs to be less than 6 in order to comply with NR 151. NR 243 is more regulating permitted CAFOs, so there's additional restrictions and requirements. But another point to make here is that while NR 151 is supposed to be applied to all farmland, there isn't really a way to enforce or measure that compliance unless these plans, these nutrient management plans, are submitted. And so they're required to be submitted if you are a permitted CAFO, or if you get cost share, or you're in the farmland preservation tax credit program. So there is kind of a separate issue here of how do we measure this compliance. And then finally, there's some other standards from DATCAP and the NRCS about how exactly or how exactly farmland owners need to comply with these standards. So there's a lot swirling around in here, but the main disconnect that I want to highlight is when we look at this issue in more detail within these TMDL efforts, and this is where another method kind of pops up, this idea of modeling water quality. In a typical TMDL, they'll use a model called SWOT that takes in inputs related to the landscape and estimates kind of the water quality outcomes in the river network. And what these models are consistently estimating, in order to meet standards, we have to reduce phosphorus by about 50% or greater in a lot of these areas. And on the kind of ag management side of things, these TMDLs are starting to see or estimate what is really required in terms of the P index to meet those goals. And they are suggesting that the current P index limit of 6 is just not going to get us to those required reductions. And so we're kind of at this point in time where there's a big disconnection emerging, and people are starting to talk more about it and are frustrated by it and searching for ways forward to potentially resolve it. So I'll hand it back to Adena for the next part.
Thanks, Eric. One of the first things that we did starting to work at the Northeast Lakeshore was convene an advisory board a number of years back that combined folks from the counties, farmers, some folks from state DNR and Wisconsin Land and Water, environmental groups, including Nature Conservancy and Lakeshore Natural Resources Partnership and University of Wisconsin Extension to help us get started and think through this. I want to clarify, they may or may not endorse any of the policy options that we're going to end up discussing, but had a lot of valuable feedback. Next slide, please. When we did our interviews, we tried to get a real variety of different perspectives. So we talked to 8 farmers, including both CAFO and grass-based, kind of smaller grass-based farmers, and some farmers on the way to becoming CAFO who are also doing grass. So kind of at least grazing heifers. And so kind of a combination of different kinds of farmers, some affected residents who are concerned about water quality, lots of private firm staff from a variety of different kinds of firms, including crop consultants and other kinds of consultants, county employees, state employees, federal, and university. We did semi-structured interviews where we had a set of questions, but then we allowed the conversation to take some different pathways depending on what people wanted to talk about. We went through IRB approval. We gave people options to be quoted with or without their name or to not be quoted. And then we also, as I mentioned, follow up to say, hey, for this quote, is that okay with your name? Or, what is your preference on how you want to be quoted? Especially because some of this is sensitive. We wanted people to have those options. And one thing just from a methodological standpoint that I thought was interesting is that for the most part, the farmers were fine using their names and that government employees often preferred not to use their names. I think given some of the sensitivities of their roles, and also EPA just did written, where they would give a written response, but not an actual interview. And so I thought that was really, I think there's some implications of that for how people's voices are being heard, and both what people are willing to say kind of on the record, what they're kind of within their institution kind of able to say. In terms of what we did next, we summarized each of the interviews for quotes and themes. We did all of this analysis and annotations either in Box online or in Word. And then from that, we kind of synthesize these big themes that came out. Next slide, please. So here's the 5 big options that we talk about here that are the focus of the report. And the first is to revise the phosphorus index limits. And Eric's going to go into some more depth on this next. And think about how to shift in general toward performance-based approaches. That's been something that nationally and internationally, a lot of people are interested in. How do we pay not just for a practice, but for an outcome? But that it can be tricky, and how you measure that outcome, whether it's through a model or something on the ground, can make a big difference as to whether people want to sign up for that program, whether it works for farmers, whether it kind of works in general. And balancing nutrient budgets, that's the third and big approach. This is really thinking a lot about mass balance, and 2 very different approaches to getting to mass balance. One is through what do we do with these larger volumes of waste at large facilities? And the other is how do we reduce both the inputs and the waste that comes out of them? One approach being through grazing. So a couple of different practices that come out of that number 3 approach to reduce nutrient budgets, and then, or to balance nutrient budgets and reduce runoff and loss of phosphorus. Then the number 4 is really focusing on advancing norms and farmer networks. So how can we continue to activate farmer leadership and the norms and networks that support farmers in making choices? And then finally, enhancing the capacity for implementation and technical assistance. So is there the staff on the ground? Is there that knowledge and the ability to access that knowledge that can really move the needle? Back to you, Eric.
All right. So I'm going to walk through the first 3 of those options that Adena outlined. And as we go through this first one, I'll take a quick side trip to just some Phosphorus 101. But the real idea here, again, with revising the phosphorus index limits, is to try and address this disconnect from what the TMDLs are showing is needed and what is actually in something like NR 151, or this PI of 6 or less on all kind of agricultural land over a given rotation period. So first, I like to think of this issue kind of distinctly in terms of phosphorus supply and phosphorus transport. And in order to really achieve kind of durable, long-term solutions to this phosphorus challenge, like, both need to be considered. And often I think we have an over focus on the transport side of things and not as much on the supply side. But basically the idea here is if you increase the supply of phosphorus kind of available for transport, that is going to increase risk. And the way that we can increase that supply, or the way that it is increased, is through this idea of a mass balance. And so we're balancing inputs and outputs, and any excess inputs are going to be stored primarily in the soil or on the surface. And if that balance continues, you'll see an increase in the levels of phosphorus in the soil. On the transport side of things, we're more focused on ideas like reducing runoff and reducing erosion, which again are very important. And both of these ideas kind of play, again, hand in hand and need to be considered together. On the transport side of things, this is where NR 151 is really focused. So we're trying to reduce erosion and runoff at the field scale. And there are many ways that we can do that, with reducing disturbance. So this is, reducing tillage or no-till, and then increasing ground cover, just having the ground covered more of the year, whether it's a cover crop or a perennial system, that will reduce erosion, and it will promote infiltration. So if we don't have any runoff from an area, we're not moving phosphorus. So what are other ways to promote infiltration comes into this. And also mentioned in NR 151 are this idea of targeting susceptible areas. So high slope or areas that have a shallow water table. We need to be even more focused on reducing transport from those areas. And then kind of this time aspect comes into play as well. We know that there are certain times of the year where nutrients are more susceptible to loss, like in the picture on the left here, kind of in late winter, early spring, where we see a big pulse of phosphorus coming off of these fields. So how is the p-index calculated? So it's got this transport focus, but you need, it's a model essentially. So this is SNAP Plus. Laura Good is on the call. Hava Blair is on the call. They can answer all the questions that you might have for SNAP Plus. And I'm just going to give it a one slide treatment here. But basically it's a model of kind of an average year in a cropping system. And it will estimate the erosion and the loss of phosphorus kind of in the sediment and dissolved forms on a kind of a daily basis, but it will give you that on an annual scale as the main output. And the things that it needs to know are things related to the location of the field. So this is soils, soil properties, slope, and kind of the average climate of that region. And then more specific kind of field management options, like what kind of cropping system do you have? How many nutrients are you putting on it? What kind of tillage practices are you doing? All of these little knobs and buttons are represented explicitly in the SNAP Plus tool. And really, like, it's always good to recognize that we are very, very fortunate to have this tool available to us that has really leveraged decades of field research to come up with these estimates of phosphorus loss at the field scale. And it's become a really trusted tool, and it's interesting to see it have all this trust across a lot of different backgrounds, from the farming community to the research community. It's just been a big success. So when we are talking about revising the phosphorus index limits, the two kind of solutions that came up in these interviews and we kind of synthesized is, one, well, what if we just reduce it across the board, or even just in the places where we know it's needed to meet water quality goals? And then kind of a sub solution to that, well, maybe we don't do it right away. Maybe we phase it in, and maybe it's not even really connected to a numerical target, but what if we just require improvement of that phosphorus index through time, rather than just a static limit? And to kind of illustrate some of this and see how it connected to the interviews, I'll just show a few quotes, starting with a county conservationist kind of about this limit of 6. And I'll just read it here for you. It's a number, it's a speed limit. It's something everybody can look at and point to. In a perfect world, from a completely water quality standpoint, different fields should have different thresholds. But try and explain that to a farmer when he's trying to decide where to apply manure and what fields need to get managed a certain way. It gets ridiculously complicated. And then I guess to add some more context to how that original number of 6 came to be, a water quality administrator mentioned to us, so when the p-index of 6 was adopted, this was before generating a lot of TMDLs. And now we have way more modeling and in some cases monitoring data to show that that's not going to be effective to improve water quality. There's going to be a need to have a discussion about stricter or new targeted performance standards. And I'll just say that the final quote kind of gets at the same idea, is what does that process look like for revising the p-index? It should be said that there was initially written into NR 151 some options for revising the p-index if standards were not met in terms of water quality. The issue has been, and this is again come up in the interviews, we now have this administrative rules promulgation process that is quite complex and there are time limits on what is necessarily a very deliberative process. And there are also new restrictions related to kind of a cost analysis. It's not even a cost benefit analysis. It's focused primarily on the costs of implementing new rules. So long story short, this is a major barrier that has come up in recent years and kind of has been it's prevented the use of some of these options that were originally in NR 151. So then moving on to the second one, again, it's related to the P index, but rather than having a set limit that people need to comply with, this idea of shifting to performance-based approaches is connecting to this idea that there are different outcomes depending on what type of practice you do. And again, we rely on things like SNAP Plus to show us those differences in outcomes across different practices. So here is just an example from a representative field in Dane County, and anybody can do this with SNAP Plus, just show a few different options, kind of going more towards a perennial-like system. We see improvements in that phosphorus outcome. So there are both efforts on the public side of things to link performance to cost share, but we have started to even see this emerge a lot more in the private sector in different supply chains where payment for performance is meant to be kind of a value add for some product. And I'll quickly just put in a plug for some tools that we have developed as part of the Grassland 2.0 project that leverages SNAP Plus and kind of makes SNAP Plus a little bit more accessible at the field scale and at the farm scale for people to just explore what some of these options might look like in a given region. So then the third category, as Adena mentioned, is this idea of balancing nutrient budgets. So those first two were maybe a little bit more focused on this idea of reducing transport of phosphorus, but I want to circle back around to this idea of, well, how do we just reduce the supply of phosphorus potentially on those fields that's available for transport? And the method here is not rocket science. This is basic kind of conservation of mass. We have inputs coming into a system, and we have productive outputs like milk or meat, and then we have our nutrient losses that we're trying to reduce. And then any balance there is going to be accumulated by that system. And so if I make this a little bit more relevant for the topic, we can look at this at a county scale or a watershed scale, and we're just doing a basic accounting of these different flows of phosphorus, whether it's feed or fertilizer coming in, and those productive outputs coming out. A lot of the times it's milk as the main productive output coming out of a region. And then having an idea of those phosphorus losses, while they're much smaller in magnitude than these other inputs and outputs, they're obviously important from a water quality standpoint. And then again, any balance, any kind of excess inputs is going to be accumulated in that system. And we've seen this happen at the state scale. This is information or data from the UW Soil and Forage Analysis Lab that shows pretty clearly that we've been building up soil phosphorus throughout kind of the late 20th century up until maybe the year 2000 or so. And we're starting to back down in some of these later estimates. But the idea here, again, is excessive soil phosphorus represents kind of this long-term water quality risk that we need to deal with. And bringing down the supply as well as reducing its transport are both essential for meeting those water quality goals. So I'll just have you remember this trend here of increasing soil phosphorus through time and then maybe a little dip towards the end. And what I did as part of this project was put some more numbers on that from the mass balance standpoint. And I used an earlier study to compare with, showing that yes, mass balance has been positive throughout that time period where we see soil phosphorus increasing. But then in recent years, we've started seeing, again, at the state scale, a little bit of a drawdown in soil phosphorus. And so that's consistent with what I have estimated with this mass balance approach. So that's good news at the state scale that we are starting to bring down this legacy phosphorus. However, it just varies a ton across the state. And so as part of this analysis, I was able to do it kind of at the county scale. And you'll see from the different colors on here that the green areas are areas where we would expect the mass balance to be drawing down soil phosphorus, and areas where it's more orangish in color, that's where we would expect that mass balance to be positive or accumulating phosphorus. And it should be no surprise that those areas where we're seeing positive accumulation still are the areas that have intensive dairy production. And so Kewaunee County is kind of an area that we've interviewed a lot of folks around, and it's an illustration of kind of one of these end members. So the high phosphorus accumulation rates are still occurring in Kewaunee County. And that will jeopardize kind of the long-term water quality goals. And so the question is, are there opportunities to better integrate mass balance analysis into NR 151 or other policies and programs? Because it's not explicitly represented in these policies currently, and we know it's an issue in some of these regions. So the solutions that came out of the report, and again, these interviews and discussions tended to be kind of in two different bins. The first is obviously something that gets a lot of discussion in dairy intensive regions these days, is the idea of concentrating and exporting phosphorus from places of excess to places of need. And digesters play a role in that, but digesters need to have on the back end a way to concentrate the nutrients and allow them to be exported. But that's certainly one option for reducing these phosphorus excess balances. The other option, though, that has come up is how do we just have systems with lower nutrient inputs? And can we even combine those with systems that have a low risk of transporting phosphorus, like in a perennial managed grazing type situation, while also being profitable? And I think there's been a lot of evidence that these types of systems can be viable in certain parts of the state, and that's something that we've looked at in a little bit more detail as part of our Grassland 2.0 project. But I will leave it there and hand it over back to Adena for the last two options.
Great, thanks, Eric. So next, as I talked about, advancing norms, so social norms are expectations about what could and should be. They don't necessarily require formal rules, but they're really considered the informal rules of the game. And that's sort of this identity connected to norms about what good farming is and what good food looks like and things like that. So I'm curious about people's ideas for how to further support farmer networks to share resources and strengthen conservation norms. Next slide. And we had a few quotes from a few different farmers that we talked with, and I wanted to share a couple of those. So the first one, talking about the watershed group in Peninsula Pride, is to show farmers in the area that no-till and cover crops actually work this close to Lake Michigan, that we lead by example so we don't have to be regulated on the backside. We really want the farmers to realize the value of what we're doing and be able to make that journey and that transition by themselves. So that kind of relates to what Don Niles says in the next quote, saying if somebody gets a ticket or a fine, they're in a negative mindset. And, talking about that approach of what's the least amount of work and effort I can put into this, just get this off my back, versus our approach is here's a little pot of money, here's a problem you've been looking at for years, try something different with no strings attached. They're trying to push something through a pipe, and we're trying to lubricate the pipe so that if they want to go through, they can get through that. And then a quote from Paul Cornett saying, it'd be naive to suggest that agriculture isn't part of the problem. It's a large part of the rural landscape and community, so it's going to be a fairly large part of the problem, but that's also an opportunity to be a large part of the solution if people are willing to work with agriculture. Dictating to farmers and beating up on us won't fix anything. That's been tried before. So I think, really a lot of commentary on kind of the role of rules, the relationship between rules and incentives, and how to motivate behavior change beyond just rule change, let's say. Next slide, please. One of the things that we learned a lot about was in the work on Grassland 2.0 on transitions to rotational perennial agriculture. Next. And I want to share a couple of findings from a dairy farmer survey that we did. This was of a randomly selected group of all dairy farmers in Wisconsin. And this was conducted winter 2023, so 2 years ago. And we got about a third response rate, which is pretty good these days for male surveys, with 661 responses. Next. We found for sure that farmers told us they were extremely to very concerned. Some are somewhat concerned about water quality, and only 6% are not at all concerned. But that the even bigger concern is farm profitability. You can just see the number of farmers who are extremely or very concerned. And what I've shown below is a picture in the orange of the amount of milk production in Wisconsin. And sadly, in that darker brown color, the number of dairy farms. So we're continuing to lose dairy farms at a rapid rate. But meanwhile, through consolidation, we're still seeing an increase in the amount of milk produced. So I think rightly so, farmers are thinking about farm profitability, but also still concerned about water quality. Next. When we look at what's important for being a good farmer, in other farmers' opinion, improving soil health is very high, minimizing nutrient runoff, considers watershed health. And these numbers are much higher than some of the questions focused on production, like has the highest milk production, has the latest technology, has the most up-to-date equipment. These are tending to be either somewhat or a little important, or some, not at all, like having quite a number of people said it's not at all important to have the most up-to-date equipment. Next. And then here's a graph that asks about 3 different kinds of dairy farmers. So in the green is intensive rotational grazers. In the brown is people who are grazing but not doing that intensive rotation, or what we've called non-intensive rotational grazers. And in the gray is people who don't graze. And when we ask them about a few different changes, so what do they support or oppose? Where 1 is strongly oppose and 5 is strongly support. So as those numbers get bigger, that's more support for that policy option. Paying farmers more for improved water quality outcomes was the highest on average, with the majority of people supporting that. And even slightly higher numbers for non-grazers, actually. Paying farmers for carbon storage was overall support, but lower. And then we asked 2 that focused on pasture, providing the same level of insurance for pasture and forage as for corn and soybeans. Was a little in the middle, with grazers supporting that more. And same with more support, more insurance support for pasture. When we asked about tougher enforcement of water quality laws, that shifted a little bit toward oppose, but a range depending on the kind of farmer. And then this idea of requiring some grazing on farms, grazers, intentional or intensive rotational grazers liked it. Non-grazers did not like it, kind of as we would expect. So a lot of different ideas, but clearly more support for incentives in some of this this analysis of the survey. Next slide. And then finally, this question of enhancing capacity for implementation. One of the big things that came up a lot was more fully funding county land and water conservation staff. We've also worked through the Grassland Project. It's been exciting to see the funding for the Grassland Academy and more technical assistance for making transitions to grazing. Next. We've seen an increase again of farmland under a nutrient management plan as just one metric. So that had started to decline actually around the pandemic and post-pandemic, but has rebounded some in more recent years. But still the majority of ag land does not have a nutrient management plan. Next. And then finally, some big picture ideas. This came out of a number of workshops that we did to where people were saying, well, here's a lot of the places that we can work. And we know that policy is just one of those. We can also work across education and thinking about alternative markets like grass-based as one, processing and making sure we have that processing facility for small scale production, land, capital. So where's the money coming from? How can people get access to land, labor and essential workers? Social norms is another big one, and then thinking about industry consolidation. So we have a lot of different ideas that go beyond this kind of narrow focus on some of the specific rules to thinking about the big picture changes that would be needed. Next. So with that, we've heard a number of future needs to further engage partners on policy options, both these incremental and transformative approaches. Consider a survey to quantify perspectives on these options, develop partnerships and data access to connect policy, capacity, and behavior change, track some of the outcomes, and continue doing the modeling and measurements for nutrient change and mass balance. So next. And thanks. I just really appreciate everybody being here. I want to make sure that we have time for questions. I know I went through that somewhat quickly, but happy to take questions and we can stop sharing so that we can hear from folks.
Thank you both for that fabulous presentation. I invite everyone to turn on your cameras if you want to, and please feel free to ask them questions. I think there might have been one in the chat that we haven't addressed yet from Rob Fish, asking if there's a metric for the level of concern from corporate farming. Are those entities playing ball?
Yeah, thanks, Rob, for your question. For sure, we included all kinds of farmers. When we think about what is corporate, I mean, technically, most farms are an LLC or a corporation of some kind, just regardless of their size. But we definitely looked at both responses from small farms and large farms, and we included most of the farmers on our advisory board were large farmers, but we did try to get a range through the interviews as well. I mean, I think when we've seen, let's say, legislative hearings, you know, there's been that, you know, pairing of Clean Wisconsin and the Dairy Business Association coming together to say, here's some of the ideas that where we've been able to get consensus. We don't align on everything, but here's some places where we have and where we can move that forward. And I think that can be persuasive. For instance, there's a transitions to grazing as potentially part of the budget. That's a big question right now as to whether that it is in part in Governor Evers' budget. Will it be in the legislature's budget when that comes out? So definitely seeing that coalition can help move the needle is my perspective on what it might be likely to.
Robert, go ahead.
Yes, thank you, Emma. First of all, great presentation. I really enjoyed it. Would you be willing to share your slide deck? I'm particularly thinking about teaching in the short term. Of course, I credit you.
Yeah, absolutely. I'm
okay. I don't know if there's a mechanism through the that can be done broadly, or if I can just contact you individually. Either way is fine. I have a two-part question. It's regarding the so I study lakes and streams, and the question has to do with, I think, what Eric was mentioning about the P and N loading trends. So the first part of the question is, why do you think those are uncoupled in the state through time? And then I'm really interested in how the ratio of loading, the NDP ratio, appears to be changing, and the potential impacts on like microbes and algae in lakes and streams. For example, might end-fixing bacteria be less favored with the more nitrogen coming down? So that's my two-part question.
Yeah, thanks, Robert. Yeah, that's a great question. So I think kind of the point sources and the non-point sources distinctly here. And I'm not a wastewater treatment plant expert by any means, but I believe if we're looking at the last several decades, there has been more progress bringing down nitrogen effluent discharges compared to the reductions in phosphorus. So in some of those major rivers where you have big urban areas contributing their point sources, so that's going to be part of the reason. On the non-point source side, though, I think nitrogen loss to these streams is a little bit more dictated by this supply element of the equation rather than the transport. So we have just seen more nitrogen fertilizer being applied to the landscape over those decades, and that's something that we've seen across the Midwest. On the phosphorus side, it's a little bit more possible to control the transport through things like conservation tillage, and we have seen progress on that front. So that's kind of a short answer to something that could be discussed at quite a length, but hopefully that gives a little bit of an answer. Thanks.
Yeah, thank you.
Nate?
Thank you. Yeah, and thanks for the presentation. It was awesome. I have a question about inputs. So Eric, you've mentioned in our intensive dairy production areas, that's where we see a mass balance that is looking worse, that has potential for accumulation and greater losses. And I want to ask why is that? And this is a question I've asked myself about 10,000 times, and it drives me crazy. I don't have an answer for it. But I guess I look at the soil test phosphorus from these areas and I say, it doesn't seem like the system should need any fertilizer. A lot of phosphorus is removed. A lot of phosphorus is lost to the environment. So what are those inputs? Why are they used? And sort of what are the perceptions around that? Because I think, I don't know, that seems like a really big nut that needs to be cracked. And I have no answer whatsoever for it.
Yeah, no, it's a great question. So again, I'll try and answer it in a short way. There is just a lot of challenges with balancing kind of the feed input side that goes into the livestock system at these large facilities versus putting that manure nutrient back on the landscape. And it can't often be spread out to all of the same fields where that feed was derived. And so you see concentration of phosphorus kind of closer in distance to some of these larger animal feeding facilities. But just in terms of the mass balance, like we're just bringing in more feed to these systems that is not being balanced by where the outputs are going, and it's just that's leading to this excess amount. I have some better figures that could illustrate that better than my words, but yeah, and there's a long history going back to just the advent of cheap fertilizer, right? Like we've disconnected our systems of kind of feed production and animal production. So we're bringing corn grains into these dairy regions from vast distances away, and that's kind of a net input into these dairy systems. Just because those feed crops can now be supplied with nutrients from cheap fertilizer rather than the inherent nutrients that were there and the recycling from any animal manures. Yeah, sorry, that was not the cleanest of answers, but hopefully it made somewhat sense.
Andrew?
Hi, thanks for the presentation. My question is about the mass balances. You showed in that map that a lot of the areas in Wisconsin are drawing down the soil phosphorus, and I was just wondering if you could comment on the cause of that drawdown being related to losses into water bodies or productive losses in terms of export. Like, you colored that map like red as being the increasing areas and green being the decreasing areas. But part of me is thinking about, do those green areas actually mean increased loading because you're losing? I don't know if that makes any sense at all. If you could just comment on
Yeah, no, that's a
that.
good point and good chance to clarify. So I didn't have kind of the size of the arrows going in and out of that mass balance, but the kind of stream export component is kind of orders of magnitude smaller than all of these other fluxes. Even though that is obviously the thing that we're most interested in. So no, it is not any kind of change in the phosphorus losses to streams that's driving that mass balance change. It's primarily in those, again, those kind of grain producing regions that are not dairy intensive, likely receiving just less phosphorus fertilizer through time. And I think that can be seen as a good thing. There's a recognition that there is enough soil phosphorus in those regions from this kind of legacy phosphorus that will support production. And so we can kind of ease back on our phosphorus fertilizer. And we've eased back, it seems, so much that we're starting to draw down soil phosphorus in some of those regions. And this is, again, something we've seen in other states in the Midwest too. But again, it's not uniform everywhere. A lot of the animal production areas, we're seeing the opposite.
Got it. Perfect sense. Thanks.
Ron?
So Adena was going over that chart about water quality and profitability. Was curious when you had the number of farms that cared about it, if you could somehow put in the number of animals that each farm raised, milked, whatever.
Mm-hmm. Yeah, thanks, Ron. Yeah, we could do that. We could look at it by farm size. I think we've talked about this before. It's like you can care about it, but what does it mean in terms of behavior? And that's true for all of us. Like I could care about climate, but still fly a lot, or, that's this sort of this attitude, concern, behavior split sometimes. And, if my guess is that probably would be similar for large farms and small farms, but I don't know. I'd have to look at it. So yeah, I can follow up with you. Thanks.
And Thomas, I think this will be our last question because we are almost out of time.
Can you hear me?
Yep.
Yep.
Okay. Yeah, I put a link in the chat of a survey that I was involved with. Sarah Lloyd was actually the lead person. Mike Bell was another instrumental person on a survey. It was on life satisfaction. I put a link into the chat so you can find that on the CIS website. There's some parallels between the questions we asked on that survey and what I heard today. Our focus was more on life satisfaction and profitability, and not so much the other practices. But there's some similarities between the survey. And one of the things that I noted listening to the presentation today is it seems like there might have been an increase in concern from the non-grazing, non-organic dairy group being expressed about environmental concerns. Back in 2007, the time of the life satisfaction survey, those folks that were in the grazing or an organic community freely expressed concern of environmental concerns, whereas the confinement folks talked about, the need to feed the world, those kinds of things. So while the studies were not, there's some parallels between the studies. it indicates a little bit maybe of a shift toward environmental concerns among the confinement operators. Of course, it's just one small indicator, which I guess is a positive thing. The other thing is that in the data that I collected and analyzed on farm profitability among the different dairy systems in Wisconsin, is that typically, there's a good old thumb rule that it takes about 3 crop acres to support a dairy cow and her replacement. And that has been a pretty good, useful thumb rule, for probably a century now, despite the fact that productivity has changed on both the animal and the crop side. But what I often found was that the confinement herds tended to have about less than 2 crop acres per cow that were either owned or rented by the farm operation. Grazers and organic folks tend to have as much as 4 acres per cow. And of course, one of the implications is that the large confinement herds generally were not able to own and rent enough land to raise all the feed they needed to feed to their herds. And so consequently, they tended to buy a bigger proportion of the feed. And so then there's a concentration of nutrients on fewer acres on those confinement operations as compared to the grazing and organic farms. And I would guess that if we got the current data, that cow to acre controlled ratio probably is similar to what it was 20 years ago. And that's part of the challenge.
Yeah. Yeah, thanks, Tom.
Thanks, Tom. That's insightful. Well, I think we're at our 1 o'clock. So thanks, everybody. Really appreciate you being here. Thanks for the comments in the chat.
Yeah, thank you
Thanks
guys
so
so much for the methods and the research discussion.